A pleasant day to you all, my wonderful children. How are you all doing? Hope you're keeping safe. Okay, yes, it's yet another time for us to study, and today we're treating the subject mathematics. I know you are so interested in this subject. You all know mathematics, and you are young mathematicians. All right, how you all doing now? Your parents, hope you're keeping safe. Hope you're always washing your hands at interval, under running water, and with soap, and applying arm-based sanitizer. Please make sure you keep safe, and if you must go out with your parents, make sure you're wearing a protective nose mask. All right, I welcome you all to yet another interesting time out with me, Mr. Ogularo, on this platform, which is online teaching. Today, we're looking at mathematics as a subject, and the topic we shall be looking at today is indices. And this topic is for week 7, and it's for primary 6. But before we go further, like I always do, it is very important I let you know what the learning objectives are. Those things you're expected to know or to have learned at the end of this lesson. So let's quickly go into the learning objectives. Now, what are learning objectives today? At the end of this lesson, each of you should be able to express numbers in prime factors in short form. You should be able to express a particular number in prime factors. Now, I will explain to you what that means. And after you're done expressing that number in prime factor, you should be able to also express it in short form. Now, I'll be showing you that shortly. And number 2, you should be able to simplify and solve simple equation. So let's go to today's topic in details. Now, what is indices? You've been hearing the word indices or index. What does it mean? Do they even have any relation? Are they related? Are they words and opposites? Okay, come with me as I explain to you the meaning of indices. I put here that indices is a number expressed in its prime factors when we write result in a short form. All right? When we write result of a number that has been expressed in its prime factor in short form, we have written that number, or we have expressed that number in index form. All right, indices is plural, index is singular. All right, indices is plural, index is singular. Now, let me quickly show you what I'm trying to say here. Let me show you what I'm trying to say here so you can understand what I'm trying to say. Now, look up here. I said when we have expressed a number in its prime factor, and if I express that number in the simplest form or in the short form, that number has been written in index form. All right? One index or a number raised to a particular power is called index, but several numbers raised to several particular powers are called indices. Now, I will explain to you what I mean. Now, for instance, if I express, are you seeing what I'm saying? Express 8 as a product of prime factors. All right. Express 8 as a product of prime factor. Now, what you do is this. You can do this and write 8. Now, you need to continue dividing 8 with prime numbers alone. You need to continue dividing 8 with prime numbers alone. What are prime numbers? Prime numbers are numbers that are only divisible by 1 and itself. Prime number is a number that is divisible or that can be divided by 1 and itself. Example 2, 3, 5, 7, 11, 13, 17, 19, 23, okay? Like that. So We will continue to divide this 8 with prime number until we arrive at 1. So first prime number is 2. 2 in 8 is 4. Next one is 2. 2 in 4 is 2. 2 in 2 is 1. So 8 can best be written as 2 times 2 times 2. That is the prime factors of 2. 2 times 2 times 2 is the prime factor of 2. Now, if I now decide to write this in short form, 2 times 2 times 2 can be written as 2 raised to power 3. How many 2 do we have here? 1, 2, 3. So it means 2 raised to power 3. 2 raised to power 3 means 2 multiplying itself 3 times. 2 raised to power 3 means 2 multiplying itself 3 times. So that is the short form. So you can say short form also means in index form. Writing this in index form is the same thing as writing it in short form. In index form, it is 2 raised to power 3. So that's what we mean by index. Now, if we now have 7 numbers with powers, for instance, e.g., if I have 2 raised to power 3 plus 2 raised to power 4 plus or times 3 raised to power 2. Now, these are indices. We call this one indices because we have several numbers raised to several powers. 2 raised to power 3, 2 raised to power 4 times 3 raised to power 2. So these are the indices. 3, 4, 2. The powers are the indices because it is more than 1. The power of 2, 3, the power of 2 here, 2 here, and 2 here. All together, 3 here is what we call indices. Do you get it now? The power of 2 here is 3, and the power of 2 here is 4, and the power of 3 here is 2. All together is what we call indices. Why the power of 2 here is 3? This one is index, this one is indices. Singular, index. This one here, index is singular. Why? This is plural. So the plural of index is indices. Is that taken? I hope that is clear. All right. So let's go to other example. Let's go to other examples as we go on. Let's go to other examples. So I say here, the result, for instance, when we write 32, when 32 is expressed in its simplest, in its factors, the result is 2 times 2 times 2 times 2 times 2. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So we can abbreviate or write this in short form as 2 raised to power 5. This means 2 raised to power 5. Let me clean my board and show you what I'm saying about that. Let me clean the board and show you what I'm saying. So it means 32 means 2 times 2 times 2 times 2 times 2. And it can be written as 2 raised to power 5. The small 5 written at the top of 2 is called index or power. Indices for plural. Now, back to what I was saying. Now, we use 32 as an example. 32. How do you express 32 as a product of prime factor? The same way. Continue dividing by 2. When you continue to divide by 2, 2 here, 1, remainder 1, 2 in 12, 6, 2 in 16, 8, 2 in 8, 4, 2 in 4, 2, 2 in 2, 1. Therefore, our 32 can be written as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Okay? 1, 2, 3, 4, 5. So in index form, it will be 2 raised to power 5. That was what I explained in that previous slide. It means 2 raised to power 5. So this 5 power here is called index or power. This 5 here is what we call index or power. So the index of 2 is 5. The power of 2 is 5. And that means 2 times 2 times 2 times 2 times 2. All right, so that is that. Let's move on to another example. So let's go to the next example. So here, we have methods of simplifying indices. Methods of simplifying indices. There are some important basic rules for simplifying indices of like terms. They are: 1, add up the index numbers when multiplying. I repeat that again. There are some important basic rules for simplifying indices of like terms. If you want to simplify indices of like terms, what you need to do is you add up, first rule, you add up the index numbers when multiplying. Okay, let's take this example. Add up the index number when multiplying. Add up the index number when multiplying. Rule number 1. Rule 1. Add up index numbers when multiplying. So, example, you have 3 raised to power 2 times 4 raised to power 3 times 3 raised to power 3 times 4 raised to power 4. Okay, let's take this example. And I want to explain to you what the rule says. Okay, so come with me, let's go to that. I said rule 1. Rule number 1 says add index numbers when multiplying. Add index numbers when multiplying. So you have 3 raised to power 2 times 4 raised to power 3 times 3 raised to power 3 times 4 raised to power 4. The rule simply says add the powers together. Add all the powers together when multiplying. Now, you don't just add powers. You add powers of like terms. You add powers of like terms. Let me show you how that is done. Open up the bracket first. You have 3 raised to power 2 times 4 raised to power 3 times this times, bring it down, times this 3 raised to power 3 times this 4 raised to power 4. Like I said, you add powers of like terms when multiplying. Add powers of like terms when multiplying. Add powers of like terms when multiplying. So, show me the like terms here. 3 raised to power 2, 4 raised to power 3, 3 raised to power 3, 4 raised to power 4. What are the like terms? Yes? Yeah, you got it right. 3 and 3. This is one like term right here. So I am going to add the powers of these together. What of the other like terms? Are you figuring that out? Can you see it over there? Can you spot it? Yes, you're right. 4 and 4 is another like term. So you're going to pair them up. 3 and 3 is one like term. 4 and 4 is another like term. So we need to rewrite them this way. So bring this one down. The first one you have 3 raised to power 2 times, followed by this 3 raised to power 3, followed by this times 4 raised to power 3 times this 4 raised to power 4. Yes, we've been able to marry or bring together the like terms. We've been able to marry or bring together the like terms. You now have this 3 raised to power 2 times this 3 raised to power 3 times this 4 raised to power 3 times this 4 raised to power 4. So the next thing we need to do, now that we have brought the like terms together, the rule says add up the powers, add up the index, or add up the powers. Yes. So you're going to write, since these 3 and 3 are the same, are like terms, just pick one of it. Pick one of it. So write 3. And the rule says add the powers. So you're going to add 2 plus 3. So you say 2 plus 3. Bring down this your multiplication. Bring down this your multiplication, say times. Since these 4 and 4 are like terms, just write one of it. Write one of it. 4. And the rule says since they are being multiplied, there is a sign of multiplication in between them. You just add the index or the power. So you say 3 plus 4. So you have 3 plus 4. So what you're going to have is this. 3 raised to power 2 plus 3 is what? 5. So you have 3 raised to power 5 times, what you're going to have here too is 3 plus 4 is 7 times 4 over 7. So that's your answer. Please do not ever make the mistake of saying 3 times 4, 12, then 5 times 7, 35. It's wrong. Do you know why? Because 3 and 4 are not like terms. They don't belong to the same family. 3 and 3, yes, like terms. They belong to the same family. 4 and 4, yes, like terms. They belong to the same family. But this is 3 and 4. They don't belong together. This belongs to 3 family. This belongs to 4 family. So you cannot multiply them. Neither can you say you would add this up. So you stop here. This is how far you can go. So this is the simplest form of this question. So our answer is 3 raised to power 5 times 4 raised to power 7. Is that taken? Is that clear? Do you understand? Any question? So our answer is 3 raised to power 5 times 4 raised to power 7. Let me go over it again. I said the first thing you need to do is open up the brackets. 3 raised to power 2 times 4 raised to power 3 times 3 raised to power 3 times 4 raised to power 4. Then the next thing is you need to collect up the like terms. Bring up the like terms together. Bring up the like terms together. So this is 3 raised to power 3. Go look for another number that the base is 3. That is that. So pair them up. 3 raised to power 2. Pair it up with 3 raised to power 3 because their base is 3. This is 3 raised to power 4 raised to power 3. Look for another number whose base whose base is 4. This is 4 raised to power 3. Here's another number with base 4. 4 raised to power 4. So you now have 3 raised to power 2 times 3 raised to power 3 times 4 raised to power 3 times 4 raised to power 4. The base are the same, like terms, the same base. So pick one and add the powers or index. You are adding the index or powers because the sign in between them is multiplication. And the rule says add up index numbers when multiplying. So because we are multiplying, we add up the powers. So we say 2 plus 3, which I have done here, times, do the same here. Pick one of the base, 4, add up the powers, 3 plus 4. So you have 3 raised to power 5, 4 raised to power 7. And that's our answer. We can't go further. All right, let's go to yet another example as we move on. Let's go to yet another example. So you can see over here, that's why my answer is 3 raised to power 5 times 4 raised to power 7, just as I have gotten on the board. Now let's move on to this exercise. Another exercise here with numbers. Another exercise here with numbers. That one says subtract rule number 2. We're going to rule number 2 now. And rule number 2 says subtract index when dividing. Subtract index when dividing. The first rule says add up index when multiplying. Rule number two. Rule number two says subtract index when dividing. So you subtract index when dividing. Now, example under that one, you have 9 raised to power 6 divided by 9 raised to power 3. Okay, let me quickly show you how it's done. We have method 1. Of this one, we also have method 2. So let me show you how it's done using method 1. So rule number 2 says subtract index when dividing. That means subtract the powers when dividing. All right, let's follow the rule. Because the base are the same base, what do you need to do? Just write one of the bases, 9, then subtract the powers, because the rule says subtract index or power when dividing, because there is a division sign, therefore the powers needs to be subtracted. So you say 9 raised to power 6 minus 3. Okay? So you now have 9 raised to power 6 minus 3 is what? 3. And that's our answer. 9 raised to power 3. Very simple, right? Very simple, right? Now, you can as well do it like this, or you know that your 9 raised to power 6 divided by 9 raised to power 3 means 9 raised to power 6 over 9 raised to power 3. And what does that mean? 9 raised to power 6 means 9 in 6 places. 9 raised to power 6 means 9 in 6 places. 9 in 6 places. So it is 9 times 9 times 9 times 9 times 9 times 9 times 9. Okay, I'm exhausted. 9 raised to power 6 means 9 in 6 places. So 9 times 9 times 9 times 9 times 9 times 9 over 9 raised to power 3 means 9 in 3 places. 9 in 3 places. So you're saying 9 times 9 times 9. All right. Now, the 9 downward here, excuse me, please. The 9 downwards here will cancel the 9 above here. So this 9 will cross out that 9. That 9 will cross out that 9. And this 9 here will cross out this 9. So how many 9 do you have here? 1, 2, 3. So your answer, therefore, is 9 raised to power 3. 9 raised to power 3, just as we got right here. Just as we got here. So it's the same answer. So if you use this method or that method, you're going to arrive at the same answer. Just follow the rule. The rule says subtract index when dividing and add up index when multiplying. I go again. Rule number 1 says subtract powers or index when multiplying. Rule number 2 says subtract index or powers when dividing. I hope that is clear. And this is very simple. So let's go to yet another example. Let's go to yet another example as we proceed. Let's go to yet another example as we proceed. All right. And that's why our answer right here is 9 raised to power 3. Have you seen it? 9 raised to power 3. So let's take some exercises. Let's take some exercises. Now, exercise number 1. 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 So, just a minute, please. Let's take some exercises. So, exercise number 1 says, write the following in index form. Very simple, right? Very simple. Easy peasy lemon squeezy. Easy peasy lemon squeezy. So come with me, let's do this. Number 1 says, simplify or write the following in index form. Number 1, you have 1, 2, 3, 4, 5. 3 times 3 times 3 times 3 times 3. 3 in 5 places. Number 2 says, Roman figure 2 says, A in how many places? Let's count now. You have 1, 2, 3, 4, 5, 6. So you have A times A times A times A. 1, 2, 3, 4, 5, 6. And the last one for number 1 you have, okay, that's all for number 1. So quickly, let me show you how it's done. It's simple. So what you need to do is this. Just count how many numbers you have here. You have 1, 2, 3, 4, 5. That will be 3 raised to power 5, or 3 index 5. 3 index 5, or 3 raised to power 5. Now, count how many A's you have here. This is 1, 2, 3, 4, 5, 6. So that would be A raised to power 6. A raised to power 6. Yes, it's that simple. Ah, Mr. Ogularu, I can do it. I know it. Okay, let me test your knowledge if you actually know it. So let's do this together. Do this. Number 3. What would this be? 2 times 2 times 2 times B times B times B. Yes? Someone is confused now. No, you don't have to be confused. It's the same way. Just count numbers of 2 you have here. How many 2s? 1, 2, 3. So that would be 2 raised to power 3. Put your multiplication before the alphabet times. How many B's do you have here? Just count the number of B's. 1, 2, 3. That would be B raised to power 3. And that's your answer. Yes, it's that simple. So answer is 2 raised to power 3 times B raised to power 3. Let me give yet another one. Let's see if you will know this. I have, okay, 5 times 5 times 5 times 5 times 5 times Y times Y. So what would that be in index form? Just count the numbers of 5s. Count the numbers of 5s. How many 5s do you have here? You have 1, 2, 3, 4, and 5. So that is 5 raised to power 5. Put the multiplication sign in between the numbers and the alphabet. So put it right here. And how many Y's do you have here? Just 1, 2. So times Y raised to power 2. Please do not ever make the mistake of multiplying Y and 5 together. They don't belong together. Okay? Another way you can write, this can be best written as 2 raised to power 3, B raised to power 3. This one can also be best written because law of multiplication brings 2 different variables or 2 different unknown or 2 different items and bind them together. For instance, A times B is AB, but A plus B is not AB. Now, it is only multiplication that has the power to bring 2 different items and bind them together. So A times B can be A is AB, not can be. A times B is AB. So in that manner, 5 raised to power 5 times Y raised to power 2 can be 5 raised to power 5, Y raised to power 2. So you can write it this way, and that is your answer. Is that taken? Is that clear? Do you understand? Can we proceed now? Yes, we can. So let's go on to number 2 of that exercise. Let's go to number 2 of that exercise. Yes, what is number 2 saying? Number 2 says, simplify the following and leave your answer in index form. Yes, we can. Can I hear yes, we can? Yes, we can. So let's go ahead. Let's take number 2. Very simple. We've just done an example under that one. So let's take it. The first one says simplify the following and leave your answer in index form. So number 2, I says 5 raised to power 4 times 4 raised to power 3. Another bracket, 5 raised to power 3 times 4 raised to power 2. Yes, very simple, okay? Now, see how I'm going to do this. See how I'm going to do this. Now, write out these without the multiplication. So, without the bracket, rather. Write out these without the brackets. So, you have 5 raised to power 4 times 4 raised to power 3. Now, whenever there is no sign in between one bracket and another, whenever there is no sign in between one bracket and another, there is an invisible multiplication sign. There is an invisible multiplication sign. Therefore, here, every term or everything in this bracket will be multiplied by everything in that bracket. So there is an invisible multiplication sign right here. So times 5 raised to power 3 times 4 raised to power 2. Just like we did the previous one. Look for the like terms. Look for the like terms. Look for numbers with the same base. The numbers with the same base. So this is 5, and here is another 5. So I said, look for another number with base 5 and pair them up, just like I paired 5 and 5. Look for another number with base 4, 4 and 4, and pair them up. So this is 4 and 4 right there, pair them up. So write this 5 raised to power 4 times this 5 raised to power 3 times this 4 raised to power 3 times this 4 raised to power 2. Because they are the same base, so write just one of the base, 5 raised to power. Now, rule says whenever you're multiplying, add up the powers or index. So it's going to be 4 plus 3 times, the same thing will be done here, because they are the same base, write just one of the bases. So it would be, since you're multiplying, you will add up the powers or index. So it will be 3 plus 2. So what you're going to have is 5 raised to power 7 times 5, this is supposed to be 4. Thank you. Thank you for that. Thank you. Thank you for telling me that. So that will be 5 raised to power 7 times 4 raised to power 5. And that's our answer. Our answer is 5 raised to power 7 times 4 raised to power 5. 3 plus 2, 5. 4 plus 3, 7. Is that clear? All right. Yes. You got the same answer. Correct. Bravo to you. So let's move on to the next one under number 2. Exercise number 2. What does that one say? I can. Can you? Let's see if you really can. So let's see what that question is telling us to do. All right, number 2 says, number 2, 8 raised to power 4 divided by 8 raised to power 2. Don't you forget, our rule number 1 says, add up the powers or index when you're multiplying, and rule number 2 says, subtract the powers or index when dividing. Subtract the powers of or index when dividing. So let's see how this one will be done. 8 raised to power 4 divided by 8 raised to power 2. I told you the rule says subtract the powers when dividing. So I will just take one of the bases. Just write 8, then subtract the powers 4 minus 2, because that's what the rule says. Take one of the bases, because the bases are equal, base 8, base 8. So pick one, then subtract the powers, 4 minus 2, because the sign in between the numbers is division. So it's going to be 8 raised to power 4 minus 2. So your answer is 8 raised to power 2. That means 8 times 8, which is 64. So because the instruction says we should leave our answer in index form, we're not going to proceed to say 8 times 8 equals to 64. We're just going to stop here. We're just going to stop here. So we will not take it to this place. Is that clear? Now, if you understood that one, why not do this for me? Do this for me. 2 raised to power 7 divided by 2 raised to power 3. Can you? Yes, you can. So let's go. The same thing. The bases are the same. So pick one of the base, that is 2, and the sign in between the numbers is division. And the rule says, if you're dividing, subtract the index or the power. So these are the indices. Because there are 2, I said indices, I didn't say index. If it is 1, index. If it's 2, indices. So subtract that. So you have 7 minus 3. So what do you have? 7 minus 3 is what? 4. So you have 2 raised to power 4. And that's your answer. And you're going to stop here. 2 raised to power 4. You won't take it any further. You won't take it any further than that. You stop there. Is that clear? Yes. That's how that is done. So let's go to the next example under the exercise and let's try to solve it. Yes, we've taken 2 down, 1 more to go. Yes, I can. Can you? Okay, if you can, come with me. So let's take number 3. Under the example, let's take that down as well and solve it and see what we're going to have. So, example 3, the question says 5 raised to power 5 times 4 raised to power 4 times 3 raised to power 3 divided by 5 raised to power 4 times 4 raised to power 2 times 3 raised to power 2. So let's see how this is done. So what we do is this. Write out, let me allow you to see the biggest screen so you enjoy, okay? So this is 5 raised to power 5 times 4 raised to power 4 times 3 raised to power 3 divided by 5 raised to power 4 times 4 raised to power 2 times 3 raised to power 2. Is that okay? All right. So now don't forget, when dividing, subtract the index. When dividing, subtract the index. Is that clear? All right. So first of all, write out what you have in the bracket. 5 raised to power 5 times 4 raised to power 4 times 3 raised to power 3 divided by 5 raised to power 4 times 4 raised to power 2 times 3 raised to power 2. Now, locate the same base or locate the same like terms. Locate numbers that are the same. Locate the like terms, which means locate the numbers that are the same. So this is 5 and 5 right there. Okay? That is 4 and 4 right there. Pair them up. And that is 3 and 3 right there. Okay? So you're not going to write them out. So you have 5 raised to power 5. The first one, this, divided by 5 raised to power 4 here, times, now that you have sorted out this divided by this, then times the next number, 4 raised to power 4, divided by, since you have paired this 4 and 4, divided by 4 raised to power 2. Now, the next number is times 3 raised to power 3. How are you getting it? Times 3 raised to power 3 divided by the last one, because you have paired it 3 and 3, divided by 3 raised to power 2. All done. I take that again. The numbers that you have paired, because they are like terms or they have the same base, 5 raised to power 5 divided by 4 raised to power 4 times 4 raised to power 4 divided by 4 raised to power 2 times the last one, 3 raised to power 3 divided by 3 raised to the power 2. And the rule says, if you are dividing, subtract the index. If you are dividing, subtract the index or subtract the power. So we're going to subtract the powers of this one. So you say 5, you're picking 1 because they are the same index. The same base rather. So you subtract the powers. 5 minus 4 times the same base. So pick 1, 4, and subtract the power. 4 minus 2 times the same base. Write 1. Write one of the bases and subtract the power. 3 minus 2. Okay? So what you're going to have is 5 raised to power 5 minus 4 is 1 times 4 minus 2 is 2. So 4 raised to power 2 times 3 minus 2 is 1 times 3 raised to power 1. Now, any number raised to power 1 is that number. So these can be best written as, because 5 raised to power 1 is still 5. Any number raised to power 1 is that number. So this can be best written as 5 times 4 raised to power 2 times 3. And that's your answer. Yes. Is it difficult? No, it's not. Can you do it? Yes, you can. So you can do it. Right. I hope you understand that. So subtract the powers because the sign in between them is division. So our answer is 5 times 4 raised to power 2 times 3. All right. So let me clean it and let's go to the last example under that exercise. Very simple, right? Yes, it is. Very simple. Okay, so let's see what the last one on that exercise is asking us to do. Yes, we're done with this exercise. So let's move on to the next thing. Let's move on to the next thing. So here, we want to look at simple equations. Simple equations. What do we call equations? Equations are mathematical expression with unknowns. For instance, you have equation could also be a term that is true or false. Okay, if I say 2, let me make you see this. If I say 2 plus 5 equals 7. Now, this is an equation. Is the equation true? Yes, because actually 2 plus 5 is 7. So this equation is true. This is an equation. So if you write a number sentence, this is a number sentence, and I've said 2, whenever you add 2 to 5, it gives you 7. Is that true? Yes, it is true. So this is a number sentence, is an equation. Now, there is another false equation, equation that is not true. I give you an instance. 5 minus 1 equals 8. 5 minus 1 equals 8. Is that true? No. Then I will put a line, I will draw a line across my equal to, like this. That means not equal to. So 5 minus 1 is not equal to 8. So this is, without that line, if I have not drawn a line across the equal to, I would have said this is false or not true. So this equation is not true because 5 minus 1 is not 8. So this is what we call number sentence. Number sentence, and it's also called equation. So an equation is a sentence that is either true or false. You get that? So an equation is a sentence that is either true or false. This is true, is a true statement, is a true number sentence. This is false, it is not true. So this equation is true, this equation is false. And this, I told you, is number sentence or equation. And I also said an equation is a sentence